My name is Rohit. I'm from the Electronics and Communication branch from the EC section. I'm giving the presentation on the signals and stochastic process on the topic of cross-power density spectrum. The introduction to cross-power density spectrum is the cross-power density spectrum is a statistical tool used to analyze relationships between two signals. It reveals the how power of one signal correlation with the power of another over various frequencies. We can see the graph over here, density spectrogram, PVT spectrum, and normal. And CPDs is a particularly useful in a field such as signal processing, telecommunication, and neuroscience and mathematical definitions. The CPDS is defined as a Fourier transform of cross correlation function of two signals. Mathematically, it can be expressed as s of xy of f infinity to infinity. You can see the over the name and input and continuous functions over here. Uh, Time and frequency and the definition interval. And the properties of a CPDS. The CPDS is a complex value function containing both amplitude and phase information. It is symmetric with respect to the frequency axis, meaning etc. And CPDS content here we can see the pictures of homemade bending systems, bending cycles, interpretation of magnitude. The magnitude of the CPDS provides insights into the how much of signals provided in related to the other. We can see the inherently of 3D able to image trap scale structures and surface geology well data potential field data. Conversely, low magnitude values indicates weak or no correlation at the corresponding frequencies. We can see the high magnitude values at specific frequencies suggest strong correlations to those frequencies. We can see the phase informations. Example, the phase of CPDS indicates the time relationship between two signals. You can see the red line and blue line here. These are the two signals. You can see the relation between in these two lines. The phase shift can show whether one signal leads or lags or sync with another. Understanding phase relationship is crucial in applications like communication system and synchronization. Synchronization. Coming to the applications in signal processing, you can see the many digital signal processing over here. CPDS is widely used in analyzing the relation between different channels in multi-channel signals. It helps in identifying common frequencies in signals from different sources, enhancing noise reduction techniques. In telecommunication, CPDS aids in optimizing the performances of communication system by analyzing interfer, interference patterns over here. And we can see the used relation between different channels in multi-channel signals. Example, different sources, enhancing noise and reduction techniques, etc. etc. Uh, there are some applications in neuroscience. In neuroscience, CPDS is employed to study the connectivity between different brain regions. It helps in research understand how brain signals interact and synchronize during various cognitive tasks. CPDS can also have used to explore relation between neural oscillations and behavioral states. You can see over here, CPDS can also be used to explore the relation between neural oscillations and behavioral states. You can see the picture of, and there are some limitations of CPDS. One limitation of CPDS is its sensitive to noise, which can obscure relationship between signals. The estimation of CPDS requires sufficient data length to achieve reliable result, especially for rapidly changing signals. Additionally, CPDS may not capture non-linear relationships, limiting its effectiveness in certain applications. Then limitation in such, when the boy standing over the bell bench, it's not working. It's not working. The estimation of CPDS 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 requires sufficient data length to achieve reliable results, especially for rapidly changing signals. Additionally, CPDS may not capture non-linear relationships, limit its effectiveness in certain applications. Estimation techniques. There are some estimation like analogous estimating, bottom of estimating, three point estimates. Comparing with the power spectral density, unlike the power spectral density analysis as a single signal, CPDS focus on the relation between two signals. PCD provides insights into the energy distributions of a signal cross frequencies, while CPDS means it provides the insight to the energy over the range of signal and signal process and frequency, while CPDS shows interactions. Together, these tools can provide a comprehensive and balance and understanding of signals, behaviors, and relationships. For example, some more comparisons, our spectral density, like a spectral density PCD, which analyzes the signal. CPDs focus on the relation between two signals. There are real world examples. We can see the heart rate variability. So there are 0.879 seconds to the 70 bpm, 0.97 seconds to 76 bpm, a blood pressure per meter to a heartbeat. A classic example of CPDS application is in studying heart rate variability between two subjects. By analyzing the CPDS of these heart rate signals, researchers can identify synchronization patterns, etc. This information is crucial for understanding psychological responses during stress or relaxation. And we can see the as per the graph, as per the heart rate variable to millivolts per it is, and there is a graph variation in this. You can see software tools for CPDS analysis. Several tools are facilitate the computation visualization of CPDS, including MATLAB and Python libraries. These tools often come with built-in functions of efficient CPDS estimating and plotting. Using these software packages can significantly streamline the analysis process for researchers and engineers. Using this MATLAB, you can see the tools over here and new subplots, variables, and fh, x, y, z. You can see some keywords over here. In the software tools for CPD analysis, MATLAB and Python libraries, it uses the MATLAB and Python interfaces. These tools often come up with the built-in functions. These are inbuilt functions, and we cannot change this come by inbuilt. And coming to the future directions, the future research may focus on improving CPTS estimation techniques to handle non-stationary signals better. Machine learning approaches could be integrated to enhance the interpretation of CPTS results in complex datasets. There are also some potential in exploring the CPTS in new fields such as environmental science and finance. And we can see the many future directions or examples like signals better stage and techniques to handle non-stationary signals better. And machine learning approaches could be integrated to enhance the interpretation of CPDS results in complex datasets. There are also potential in exploring the CPDS in new fields such as environmental science and finance and technical education over the ranges of 0 to 10th and 10th to colleges. And we have the conclusion of the cross-power density spectrum is a powerful tool for analyzing the relationship between different signals. Its ability to provide insights into both magnitude and phase correlations makes it invaluable in various fields. Understanding the utilization of a CPDS can lead to advancement in signal processing, neuroscience, and beyond that get we can get many things over the range. We can more than suspicious ranges. The CPDS density spectrum is a powerful tool for any analyzing a relationship between different signals. In between two different signals, the CPDS plays a key plays a key role in this, and we can conclude by that CPDS is very important and very needful to the two different signals, etc. And thanking you for this opportunity.